So it's all his fault. And if you are smart, you will tell your lawyers to sue me for the prorated amount of your tuition.
Let's
I robbed you of 7 minutes of his wisdom. At the end of the talk, you will be grateful.
Down here.
Right now is the...
Must wear sunglasses everywhere. But I'll make an exception.
Yeah, yeah. We already started nine minutes ago. We've been broadcasting live for 9 minutes
You should
here.
have already introduced me.
Well, I was thinking of it. Oh, okay. You've got a Mac. OS 9.1. Well, I'll wait till it actually starts there.
Well, I can act. Well, I don't just I don't know stuff.
Can you tell jokes until it warms up?
I can do an introduction.
Okay, well, okay. Okay, well, let us start now. Okay, welcome to the Computer Security Seminar from Purdue University. We're a little bit late today. And it is all Victor's fault that we're late. Today's speaker is Professor.
No, not professor.
Not professor.
Not professor.
Right.
I work for a living.
Abe Singer. Okay. Today's speaker is Abe Singer, and he will talk about towards mining Syslog data. Okay.
Okay. So I am where I'm coming from as I find my presentation here. The way my display came up, I actually can't see it over here. So
Isn't it on there? Oh.
no, it's not mirroring at the moment. And maybe after a second I'll get mirroring working. But let me just try and get it on the screen first. It should be under.
Purdue 2004.
Thank you. I also went to school, public school in California, which means I can't spell. Okay. Whoops. That should have brought up the show. Hello. Oh, now I've got a more interesting problem. I wonder if that has to do with my video display. Let me see if I can fix that. So I work at the San Diego Supercomputer Center in the Security Technologies group. And we're responsible for operational security for the center. And one of the things they let me do is do research that can benefit our operational security. Okay, now I have the same thing on both displays.
And they're both wrong?
They're heading towards both wrong. That's the most interesting problem I've had in a while.
Change the resolution.
Yeah, but it's not actually. It doesn't want to quit either. Okay, I'm going to have to apply the Microsoft solution to this.
No, but it will make it much more interesting and less predictable.
Okay. But I actually, most of my talk is talk and not slides, so I can actually talk about this. So I'm a security practitioner. I get to do research. And so in the process of trying to manage our systems and do intrusion detection, one of the things I spend a lot of time doing is trying to get useful information out of our system logs, especially intrusion detection related information and things like that. What I want to be able to do is do data mining of Syslog data. I think there's a lot of valuable information in Syslog data, and data mining can tell me things, help me find things in my system logs that I don't know about. We've been archiving our Syslog data for the last 8 years. So I have about a half a terabyte of syslog data that I can analyze and maybe learn some interesting things, find some patterns and trends and things like that. And like so, I'm really interested in finding things that I wouldn't know to go looking for. And so on, and things that would be useful for intrusion detection, useful for forensics, maybe even just useful for system management. I'd like to even be able to, there's some simple questions I'd like to be able to answer. What are the 10 most frequent messages I see in my system logs? Even more interesting is what are the 10 least frequent messages in my logs? We collect several million lines a day of log messages. There's no way I'm going to find those by reading them unless I don't get any sleep whatsoever. So that sounds pretty simple to do, but it's actually really hard when you start looking at syslog data. And I will actually have examples if this comes up. Syslog is a basic logging mechanism. For those of you, how many people don't know what syslog is? Okay, then I'll talk really fast about this. So it's a basic logging mechanism used. It's basically the only thing that applications use to log unless they write to their own log files. There are other logs such as process accounting and so on, and WTemp, things like that. But those only contain stuff from the kernel. And those are relatively easy to work with. The syslog protocol itself provides for, hopefully I get my document up here, provides for transport of log information, but doesn't actually provide for any formatting of log information. So there's tons of useful security-related information. I already get a lot of good information, direct information like things like authentication failures and so on. Haha! Okay. So maybe I can actually do something interesting here. And so on, authentication failures, connections to services, refused connections, things that indicate probes. But there's also a lot of indirect data, side effects of a compromise, such as unusual privileged activity, or things we wouldn't expect to be seeing in the logs. Things that by themselves don't say there's an intrusion, but combined with some other events usually indicate that, or combined with some outside knowledge. That sort of thing. Also looking at things like resource utilization, having thresholds for normal activity so we can see abnormal activity would be useful. And correlation of events against outside events. I've learned that no presentation is considered academic unless you have at least one chart in it. So this is my one chart. This is a simple thing I did several years ago. This is just a histogram of probes over time, over a period of a couple of weeks. That we saw, refused connections to services that we weren't running. This by itself doesn't say anything super interesting unless you know that this is the time that Kevin Mitnick was let out of jail. For those of you that don't know who Kevin Mitnick was, he was supposedly the FBI's most wanted computer hacker. He was arrested in part due to intrusions that he did at the Supercomputer Center, even though he was actually arrested for other activity, what he was guilty of was other activity. Kevin Mitnick was due to be let out of jail. Shortly before then, he did an interview with 60 Minutes that aired here, aired on that day. This is the day he was let out of jail. Okay. I would be interested in taking our logs, putting in a whole bunch of dates of events that we think are interesting, and having something tell us here are the things that were abnormal on those days, or that were different on those days, that sort of thing.
It wasn't let out with an injunction not to touch the computer for several years.
Yes, I'm not saying this is due to Kevin. This is due to lots of Kevin fans or wannabe hackers that basically saying, let's go get SDSC for Kevin. Actually, this is a machine that lives on SDSC's network, but it's actually managed by Satomu Shimomura. So he gives us his logs to look at, and it's a useful way to find people probing things. So there's a lot of different syslog messages and a lot of noise. There's a ton of stuff, nominal status message, redundant information, and some messages that don't actually even say anything useful at all. like I said, we collect several million lines of messages per day, and the small and maybe interesting ones are going to be missed. Even the large and interesting ones might be missed if we don't know they exist. So I think data mining can help me find patterns of activity that could be interesting. Maybe they won't be interesting, but then at least they're nominal status information. Groups of message, looking at message frequencies, things like that, that could be something worth investigating, and so on. And CERT has this wonderful quote in one of their documents. It says, look for anything that appears out of the ordinary. But how do you know what's out of the ordinary until you know what's ordinary? So anomaly detection is actually the most common thing that's prescribed. Just about everything you read about logging, including stuff I've written, says go look for the weird stuff. Go look for something unusual. But it requires normal activity to be identified, along with things like thresholding and windowing. If you want to look at user logins that are outside of a normal period of time, you have to know what the normal periods of time are and that sort of thing. So data mining can do this stuff for us. But data mining requires your information to be formatted, to be defined. Data mining is basically an application of statistical analysis, at least the data mining that I'm looking at. So you need to know, data mining tools need to know what the input is. So things like databases, XML formatted data, processing counting files, things like that are relatively easy. Network data are relatively easy to use data mining techniques on because we know the format. But Syslog data isn't clearly defined. There's no data dictionary or anything to work with. There isn't even a standard language for it. A few examples of Syslog messages, just to give an idea of what we're looking at. Syslog messages have what I call a header and a body. The header is a relatively regular format. Timestamp, host name, what I call a service name or the process that generated the message, and a process ID. This information is generated by the Syslog API or the Syslog server and so on. And then the body of the message is the rest of the message. These are 3 different message bodies, just to show some of the differences. This is basically arbitrary text. Even though this is where the real interesting information comes from. This is arbitrary text written by the programmer that writes the application. And as Larry Wall, who wrote Perl, once said, the 3 virtues of a programmer are laziness, impatience, and hubris. So what Marcus Rannum once said was, programmers should not be allowed to write log messages. And basically, programmers write what they want. They often write this stuff, or usually write a lot of this stuff for diagnostic purposes while debugging their own code. The Syslog protocol, the Syslog environment itself, was actually put together by Eric Ullman. And he actually said the only reason he did it was to get the printf statements out of his code. So we've got this tool that wasn't even actually written for what we're using it for, but everyone uses it. And everyone uses it differently. And the people who are using it are thinking about how other people are going to use it. And what's the fun in writing, in going back and cleaning up your log messages and making sure they're formatted, make sure they're easily parsable, writing descriptions for them. That's the laziness and impatience part. So for example with this, I decided to just work through and write code that will parse out the header information of messages so I could separate things by service. So I could at least group things by the service and maybe look at some of the patterns that existed. So this took me actually several days of writing regular expressions to match headers, and identified 23 different header formats in 1 week's worth of our Syslog data. Some of them don't have a host name, some of them do, some of them don't have a service name, some of them don't have the process ID, some of them have additional information. This message was forwarded by this host, things like that. That alone was a pain. Coming up with ways to parse the actual text is much harder. And this is why I think, as far as I know, there's very little work that's been done on data mining of Syslog data. I've come across a number of papers on data mining for security, but they've all worked with things like a network or system call traces. And I'm pretty sure it's because the data was easy to work with, it was clearly defined and that sort of thing. If people stopped to look at Syslog, they would get so caught up in trying to extract the data that they never actually get to do their data mining, which is kind of where I'm getting to. So there's also lots of tools that call themselves log analysis tools, things like Swatch and LogSurf and so on, but they're actually just log parsing tools. What they expect as input is a description of the log messages you want to work with. So you have to know what you're looking for in the logs in order to work with those tools in any useful way. So to get to my actual goal, which is data mining of Syslog, I need to develop a catalog of messages, a way I can uniquely sort out messages based on what I'm calling a message type. Now I'm going on the assumption that any given Syslog message, and also in my experience, contains some hopefully descriptive text and optionally some data. As an example, here's a simple message that has some connection refused from, and the data portion is the IP address in it. What I want to do with the message type is be able to identify like messages. So another example, whoops. I lost one of my examples. Well, what my example was is here's a connection refused from one IP address, another message is a connection refused from a different IP address. I would consider to be the same message. Okay, so that would be a different message that would not be matched with that message, and so on. I'm defining the messages, or I'm thinking about messages as a collection of variant and invariant text. So what I think I want is a set of templates or patterns that are used to match messages which identify the variant and in-portion variants of the message. Now, patterns need to be good enough. There are obvious, my slide got out of order. There's the like messages, there's the unlike messages. So this is what I'm thinking maybe a template looks like. Okay, where %s is a string. Could be %string, could be %i for IP address, or something like that. There are obviously trivial patterns that will match messages, but really aren't useful for anything. So patterns need to be good enough or best match to actually be useful. So I've identified some properties of message types and their patterns. Some simple properties. If you have a set of patterns to match against, any message should match just one pattern. If a message matches 2 or 3 patterns, your patterns aren't good enough, or something else is wrong. But a pattern can and should match multiple messages. If a pattern matches only one message, it's probably too good, or something like that. For instance, if my pattern here had the IP address in it, it would match that message, but it would match only that message and not be very useful, and would not be identifying the invariant portion of the data. So in addition to that, the service type of the message goes along with the message type, because you can have two. You might have the same message with 2 different services that in context has different meaning, and so on. So separating things by service or identifying with that I believe is necessary. And at this point, when I've had a conversation with people about this, usually I get to this point and somebody says, well, that's not so hard. Just sit down and start writing patterns and weed out, you take those patterns, use them to weed out the things that they match, and then write some more patterns and do that until you're done. Well, that is a way to do it, but it depends on how many different patterns we're talking about. So people say just write them, but my question is, how many are there? And I think that if there's less than 1,000 different message types, it's feasible to write these patterns by hand. But if there's something on the order of 10,000 or more, it's not feasible to do it by hand. Even if you could, I think you would be committed by the time you were done. So I actually posit that there's something on the order of 10,000 messages. Okay, and based on some experience I've gotten with this, I think we're on that sort of order. And actually some of my preliminary evidence for this is I sat down, since I'm able to separate stuff out by service, I took just SSH activity, and I sat down and said, let's see if I can write a set of templates that match SSH logs. I stopped at 83, and I wasn't done, that sort of thing. I was able to also identify, through header parsing, something on the order of 120 different services running on our network. So if I were to extrapolate, and I know I'm extrapolating from a single point here, but if I were extrapolating that there's something on the order of 100 messages per service, okay, that's something in the order of 12,000 different message types I'm dealing with. Somebody else wants to sit and write patterns for me and do this by hand, that's fine. But I think what we actually need is an automated mechanism for deriving this sort of stuff. Something that can take a batch of log messages, a big pile of log messages, which, gee, do I know anyone that has a big pile of log messages? Analyze them, compare them, and find messages that look similar enough, identify the similarities, identify the variations, and tag those two properties and produce templates from that. I'm not sure how to do that yet. I have a couple of ideas, but that's what I think I need. And that's what I need just so I can do what I really want to do, which is the data mining portion. So some assumptions that I'm working with, and also this is also derived out of having talking about this before and seeing some of the arguments that come back. Often people come to me and say, well, how is your analysis tool going to identify the good logins from the bad logins, or the things that indicate intrusions from other things? It's not, what I'm trying to do is not, I don't need anything at this point that attaches meaning to what the messages are. I just want to be able to separate them. And once I can separate them, then maybe by hand I can do that, or something else can do that. Pattern discovery might tell me useful things. Sometimes it's combinations of messages that by themselves are normal, but in combination are something abnormal. So I'm trying to just identify and separate messages, not assign meaning to them. And Victor's probably going to tell me that I need to assign meaning to them to get anywhere. But this is what I think I'm trying to do. The other thing is that the other argument I come up with is people tell me, well, how are you going to make that efficient? And not with tequila, that comes in a second. I will worry about efficiency once I figure out how to do this, because I'm not convinced that it's doable. I think it's doable, but I'm not sure. And I'd like to know it's doable, and then I can worry about making efficient. Plus, I have lots and lots of big computers that I can play with. So that's useful. If I can get to this point, if I can get this catalog of stuff, besides doing data mining, or doing the more extended data mining, there's some real simple things I could do with the catalog messages. Simple frequency analysis, extending the 10 most frequent and the 10 least frequent to, what is the distribution of messages, whether frequency distribution of messages and things like that. Like I said, it'd be useful for doing simple pattern discovery, just being able to separate messages. If I give each different message type a number, just identifying simple patterns of messages without going to depth of what their contents are, without even looking at IP address or anything, might show me some interesting patterns of activity in log files, especially in some cases if I correlate those with outside activity. It would also be useful for anyone that's writing log parsing tools. And part of where I even started with this was just trying to sit down and use Swatch and write patterns for Swatch and write ignore lists for Swatch. I wanted to put in all the things I wanted my log analyzer to ignore, and I realized I didn't know what those things were. And as I kept working on it, I kept finding more and more things. It became one of those it was kind of like trying to dig a hole in sand with a small scoop. I'd take a scoop out and it would seem to refill. I wrote something like 2,000 ignore patterns, and the amount of information that I was getting that wasn't matching those ignore patterns didn't really seem to be substantially smaller than when I started. And that's where I started going with trying to figure out how to automate this. Once I can get those patterns, things like classification and labeling and assigning meaning to this stuff, I think I can do by hand. If not, we'll find another way to do that. And once this is done for a batch of messages, the patterns don't need to be derived again. Everyone can use them. People can add to them. So I think it's a process that scales over time. I did try and make some progress on getting some work done, and in part, I was hoping I could find somebody that would do it for me. So I had a few conversations with Marcus Ranum, who started out with, "I don't think you can do that," and then came back with, "I think you can do that. It'll be pretty easy." But he also was going on an assumption that there weren't that many messages, and we actually made a bet as to whether there would be something I think our bet was whether there'd be more than 1,000 or less than 1,000 messages. He bet less, I bet more. The bet was a bottle of tequila. And he got far enough with the work that he bought the bottle. So what Marcus did...
Messages.
Well, patterns or what I also called templates, what I showed here. Yeah. Yeah, I'm having a terminology war in my own head. So what Marcus tried doing was, I would say, some basic statistical analysis of word position and frequency in messages. He took a message and developed just a candidate template. Just identifying things that were strings and numbers and some things like that. So what he was doing, he did a lot more detail than I'm going to explain here, but taking a message like what it looks like up above and reducing it down to a template that looks like that. What he also did is record the actual strings that match those in frequency tables. So this is position 1, SSH was seen 10 times and that sort of thing. In position 6, the username Abe was seen once, Joe was seen 4 times, that sort of thing. He ran this against a whole bunch of our data and then tried to write some tools that would go back and look at the frequency, say, gee, if I see, if I saw 10 messages and I saw SSH 10 times, I'm going to treat that as an invariant string. Or if I saw it, more than 90% of the time, I'm going to treat that. I'm going to build another template, apply that, see what's left, and see where I get. This seemed like a good idea at the time, and as he kept working on it, he kept getting stuck on different sorts of variations on messages, things he didn't anticipate, repeating sequences of things, like a whole list of email recipients. We found some wonderfully difficult to parse log messages, like quoted strings that had quotes inside them, things like that. Things that may actually, you could argue, are impossible to quote. He had problems with things, hashes, things that ended up being random strings, and that sort of thing. It eventually became an iterative process. He would find some other variation on this that he hadn't anticipated and have to basically put more rules in his code. And we don't want an iterative process. I think there's too much stuff and so on. So he kind of threw in the towel on this. But one of the things we did learn was that there's a lot of different log messages, and it's pretty hard. So like I said, I haven't done a lot of work on this. I haven't found much work done on this, but there are a lot of things that I could learn more about and some other directions I could go. Natural language processing may be a way to approach this, or it might be using genetic sequencing algorithms, turning messages into basically a string of tokens and looking for fragments of strings of tokens that match between messages in different locations, which is similar to what genetic sequencing does. Genetic sequencing does it with very long strings of very few tokens. I would be doing this with relatively short strings of a lot more different kinds of tokens. So that's basically where I'm at. This is more of a problem statement than a solution. I don't have a solution, but I know what I want to get. If people have ideas or recommendations, or somebody wants to make this work for me, that would be fine with me. Because then I can get to the fun stuff, which is the data mining, because I'm hoping to actually learn some new things about logs, learn some new ways to analyze them, so that we can do better intrusion detection, better forensics, even just better system administration, and things like that. And that's it. And questions?
Questions? Could you go into a little more detail what you meant by using natural language processing in the
Not much, because at the moment I don't know a lot about natural language processing. If Victor has something he wants to add, that would be better.
Processing will definitely be helpful here. The problem is that it is, as you know, pretty time consuming to create. Basically, you need to create a syntax and the lexicon. That is what defeats the procedure that your friend Mark was trying to do, is that there is variation in the actual incidence of tokens. But if we could generalize from that into what it is syntactically, chances are that this variation of tokens would not affect the actual pattern. That is, we would recognize the pattern, we would understand that it is there are these variabilities. Like, for instance, to give you an example, which I don't think will occur in the law. If we know in natural language that in this sentence, like an English sentence, it should typically start with a noun. To use my own name, you may start sentences about something I did, or more typically forgot to do, with Victor. Now, if we put Victor in the pattern, we'll find all the references to Victor. But sentences which begin with core, your name, will be recognized as a different type, but they shouldn't be. And so Victor and core should be put in the same category. Moreover, the pattern should allow for Victor and core and any other group of nouns or whatever. So this is what needs to be done. And using straightforward syntactic categories will not help. You need to use the categories, the concepts from the logs, from the Syslogs. That is, like for instance, it's clear that any two sequences of numbers are not created equal. We must recognize a certain specially formatted sequence as an IP address. That's definitely a category. And so there will be patterns which have an IP address. Maybe it's just one pattern. Maybe there are more patterns. So basically, you need to be able to recognize every item, say between the blanks. That is a word. It's simplification. In some cases, it has to be like a sequence of two more words. We must recognize them as a Syslog concept. Have an inventory of those, and then you can go over every message and recognize it as belonging to a certain type. This will definitely work. It has always worked. The question is whether it can be scaled down to something other than your inventory of every single word occurring in your half terabyte of messages. Whether something can be done like on a certain small corpus of it, and then statistically or otherwise extrapolated to the rest. That is, do a little bit by hand, and then trying to generalize from this tagged corpus, as we call it, to the untagged corpus. So there are definitely possibilities, but it's emulating NLP techniques rather than doing the actual NLP. Am I making any sense?
So the problem exists before even the semantic layer. It exists before it's sentential or syntactic.
Well, yeah, I mean, to do anything that is correct, at this point, he doesn't really need to understand what every message is. He just wants to have a pattern. for it.
I just want to sort them out.
Yes, as they mentioned on the basis of our exchanges, I maintain that it's never enough. You really want to understand the content, and it is not much more of an effort. Normally, you sit and wait until the researchers understand it by themselves, because otherwise they won't believe it.
Go ahead.
I'm sorry if you have gone over this already. I just want to know, what do you expect to gain by mining Syslog data over other data, like for example, just the system call traces or the network traces? What do you think that you'll gain additionally? What is the advantage?
Okay, let me say more what I hope to gain. I hope to learn something like what would be really cool is if I could discover patterns that indicated intrusions that I never knew happened on my systems. For instance, I don't know if I'll find that or not, but I won't find it until I go looking for the things until I have something that shows me the things I don't know about. So for instance, there's that. Also, things like looking at process accounting or system call traces. Well, system call traces aren't things that people normally record in terms of administering systems, but people do normally collect log information. So like I said, I have data. I continue to collect data. A lot of information is in there already. So I'm just trying to find a way to get it out. And system call traces show you certain things, but I think there's other things they don't show you. One of the things they don't show you is some of the interpretation of activity. What some log messages tell you is the interpretation of an activity. And I'm going to reverse it after I said all kinds of bad things about programmers. If they write good log messages, the log message is actually telling you what's actually happening, not just a sequence of events occurring.
Has anybody in the group worked with Professor Carla broadly in electrical and computer engineering? Unfortunately, we have lost her to Tufts. She was doing something similar to called data mining without this categorization that Abe feels he needs. She looked at the statistical properties of Syslogs for one individual user, and trying to capture unusual patterns which would indicate that it may be an intrusion detection with somebody or stealing the password or whatever, somebody pretending to be this user and doing something very unusual. So this is a kind of a similar activity, but it is simpler because with Carla's material, it is one individual user who is doing things.
Yeah, and it's a relatively small amount of messages that she's looking at.
Right, and sort of in the same.
Yeah, so it's actually, you can do it by hand because it's a small amount of different
messages.
messages.
Tons of, the user logs in 20 times a day. But it is, typically we all do the same way.
Yeah.
The same way.
Yeah. Actually, to answer your question a little bit more, something else that could do, once I have a catalog of messages, I can have a system tell me when it sees a message that it's never seen before. And I know when we have intrusions, I often go and look at the logs around this time to see what I can learn happened. And sometimes I find messages I didn't know about, or messages I'd never seen before. I think in some cases there are messages that were never actually generated before. That sort of thing. You had a question, or did I answer it?
Okay. Is anyone sharing their swap signatures now? I mean, that's been around for a while. And
There's some.
Have like standard signatures that people would be sharing.
You also get things like new version of SSH comes out and they've changed the log messages in some way, or that sort of thing. So there's some, but not on the scale that one would need. That sort of thing. Not on the order of 10,000 patterns to work with. And some of it comes from a lot of the people doing that we're running 4 or 5 different operating systems at STSC, and so different OS versions and other things. So what you get is somebody writes it for instance, doing the SSH patterns might be, I might have fewer patterns if I was working with one version of SSH, but these are patterns that match 4 or 5 different versions, things like that. Other questions?
I just want to mention, IBM has done a lot of work in this area. They have something called log analyzer,
Mm-hmm.
and it's got a parser and all the graphics stuff.
Okay.
So you,
Do they actually have,
It's sort of
do they have a
half-
catalog of their messages or log messages that it will automatically parse?
clever algorithms to do the mining.
Okay, yeah, I'll bet they
It's-
don't, I bet they require you to provide the actual patterns to be matched.
It's a system, also a system log analyzer.
Right, right.
What, to the extent that, I'm not sure we're talking about the same thing, so maybe there's something better. What I'm familiar with from IBM, their premise is this: given this set of patterns, this is how it will work.
Right.
There is no pattern recovery, pattern discovery
Yeah, yeah.
there. And this is the first thing that you want.
Mm-hmm. Yeah.
Could you apply the million monkeys solution to this? No, if you had a package that came with a set of patterns,
Mhm.
2 or 3, 500 that you developed yourself,
Mm-hmm.
and then you distributed that to 100 sysadmins, and they would categorize the unique messages that they came up with, and those would go back in and then get distributed so that everybody would benefit from the new patterns. Okay, rather than you having to do 10,000, you've got 100 people
Each doing,
10,000.
or
and-
each doing, that's, might be an approach. I don't have a lot of faith in getting enough people to actually contribute to it, to be honest. Yeah, but how many people want to do that? And also, it turns out writing these patterns can be tedious. Certainly, writing with regular expressions can be very bad. Regular expressions are good for some things, but when you have to write them by hand and debug them, it takes entirely too long
But
to do hundreds of them.
graphical
That sort of
tool
thing.
that would show them, okay, here's a new message I haven't identified, mark over the things that you always word, mark over the.
That is actually where I was going at one point, or before I got to this point, I was thinking about some things like that. But there will also always be new messages and other things. This is if I can, that's a way to do it. And maybe the way is just to get some funding and hire a whole bunch of interns for 6 months or something like that. But if I can come up with this, I think it'll have a lot of useful applications.
Okay, why don't we thank our speaker now?